Okay, this video is for Chapter 4, Electron Configurations. You should have already learned how to do the long form of electron configurations. But now we're going to teach you how to do the short form, or sometimes we call that the noble gas notation. Now, you will definitely need a periodic table during this video. So if you don't have one handy, pause this video right now and then go find one, because you're going to want to have one sitting next to you. Now, you also need to take notes while you watch this video, and we've already written out all the hard stuff for you, so you have no excuses not to take notes. But in your note packet, if you turn to the page where it says Noble Gas Notation, video number 3, you're going to notice that these arrows are not written in for you, and so you're going to want to do that quickly in your packet. Make sure you do this so that you know the direction that you read this, because this rule is read diagonally. That's the name of the rule, the diagonal rule or the Aufbau rule. And you might remember that in the s orbitals, you can only put up to 2 electrons. In the p's, you can only put up to 6. In the d's, up to 10. And in the f's, up to 14. So you can have numbers lower than the numbers I've just written down, but you just cannot have numbers higher than that. Now, to do the noble gas configuration, at first is going to take you a little bit longer to figure out, but once you get good at it, it's actually going to be shorter than the long form. Now, for the test, you will need to be able to do both forms. So you have to learn how to do this. And it's actually pretty easy. Now, the way you're going to do this is you're going to find the column on your periodic table, which includes the noble gases. Now, if you don't know which column that is, it's the very last column. Columns go up and down, and it's either numbered 18 or 8A. And the noble gas elements are helium, neon, argon, krypton, xenon, and radon. You will always be using one of these 6 elements to start out your noble gas configuration, the short form of the electron configuration, okay? Now, what you're going to do is find the one that has the highest number that comes before the element you're trying to do. You're going to put that noble gas in brackets. Now, brackets are not parentheses. Brackets have squares. Okay, corners. And those are going to represent all of your lower level electrons. I'll explain this as we actually do an example, and then you just have to put the remaining electrons in. So let's start with an example. We have aluminum. That's element number 13. So find that on your periodic table. Now, it has 13 protons, which means it also will have 13 electrons. So when we're done, we should be able to check that we did it right by counting our electrons. Now, with your periodic table, find aluminum, and then look at the column, the last column of the periodic table, and figure out which noble gas is the highest number that comes before it. And you should be able to figure out that that element is neon. We don't want to use helium because there's one above it, neon, and we can't use anything higher than aluminum is. So that, by writing neon in brackets, we have already taken care of 10 of our 13 electrons. Now, how did I know that there were 10? Well, neon is element number 10. So if I've already taken care of 10 of all these electrons, and there are 13 total, I only have 3 more. Now, the question is, how do I know where to begin? I can't start at 1s again. So I look at aluminum, and tell me what row of tell yourself what row of the periodic table it lives in. Now, aluminum, if you look at it, it lives in row 3. That means when we use our diagonal rule, we're going to want to start at 3s. Okay? So we're going to start here at 3s, and we can put up to 2 electrons in the 3s. So now we're up to 12 because we have 10 from neon, 2 more. And so 10 plus 2 is 12. We only have 1 more to go. After the 3s orbital, we go to 3p. That's how we would do this. Diagonally after 3s, you'd go to 3p. And in the 3p orbital, you can put one of those remaining electrons. 3 plus the 10 equals 13. So we've done the shorthand notation for aluminum. Now we're going to try another one. This time, you're going to find scandium on your periodic table. Scandium is element number 21. Now, you want to use the noble gas that comes before scandium, the highest number. So if you look back at the noble gas column, The noble gas that has the highest number that comes before it is argon, and it is element number 18. So by writing argon in brackets, we've taken care of 18 of our 21 electrons. That means we only have 3 more left. But where do we start? Well, we look at scandium, and we find that it lives in row 4 of the periodic table. So instead of, now we look back and we say, okay, well, we can start at 4s. And after we fill 4s, we'll go to 3d. So how many electrons can you put in that 4s? Well, any s orbital can hold up to 2. So if I have 18 plus 2 more, that's 20. I only have 1 more to go, and it goes next into the 3d. And that's the electron configuration for scandium, and we've done it in a shorter way than we're used to from before. Now we're going to try barium. And with barium, you've got to find it on the periodic table. It's element number 56. So we're going to try to find the noble gas that comes before barium. Okay, that noble gas is xenon. And that noble gas is element number 54. Now barium itself lives in row 6, so we're going to start at 6s. And we can put the 2 remaining electrons into that 6s. So 54 from xenon plus 2 more makes 56, and that is barium's short form. Now if you think you're starting to get the hang of this, why don't you pause the video right now and try the last 2 on your own. If you think you need more help, keep watching. Once you've tried those last 2, you can always replay the video to see if you're getting them right. Now PB, find that on your periodic table. It's element number 82. That means it has 82 electrons. You want to look for the highest numbered noble gas that comes before it, and you'll see that xenon is the only one that will work. Now that still has 54 electrons. So now we have a lot more electrons to go before we are finished. Now PB still lives in row 6. So we're going to still start at 6s. And that's going to take care of 2 of them. How many more do we need? Well, originally, if we had 82 and we had only 54, we were going to need to deal with 28 more. We've taken care of 2 of them, so now we're down to 26 more. After the 6s, if you follow the diagonal rule, you'll find you need to go 4f. And since we have 26 remaining, we can put 14 in there. So if you look at your total, we'd have 54 plus 2 plus another 14. That would get us to a total of 70 electrons. We have 82 total. So I have 12 remaining. After the 4f, I go to 5d, according to my rule, and I can put 10 in there because I still have 12 left. Now I am up to number 80. I have 80 electrons. 54 plus 2 plus 14 plus 10 makes 80. I still have 2 left, and they go into the 6p. So I can say 6p2, and I should be done. Now you can always go back and check. Remember, you have xenon has 54 plus 2 plus 14 plus 10 plus 2 will equal the 82 total that you wanted. And our last practice problem here is for platinum. Now you're going to find the platinum element on your periodic table. It's element number 78. So when we are done, we're going to have 78 electrons that we'll take care of. Now platinum lives in row 6 of the periodic table. So the noble gas that comes before it is still xenon, and it has 54 electrons. So we still have a lot more to go before we're done. We start, because it lives in row 6, at 6s, and that's 2 of them. So now we're up to 56. After we get through the 6s, we go to the 4f. We can put all 14 of them, and that takes us to 70 even, 70 electrons. I only have 8 remaining. From there, I go to 5d, and I can put 8 remaining electrons in the 5d. Now, that is the short form of the electron configuration. And once you get the hang of it, it is actually really much shorter and quicker than doing it the long way. But we do expect that you know how to do both for your test. We will practice this some more in class the next time we meet.